Hello friends, in this video we will formally analyze the insertion sort. So as we know that sorting time will depend upon my input size n. So if my input is, let's say, only 3 elements, then it will take very less amount of time to sort these 3 elements. But if my input contains, let's say, 100 elements, then definitely the time will be more. So therefore we can say that overall time for implementation or execution of this algorithm will be a function of my input size, which is nothing but, let's say, small n. Now this is the pseudocode for the algorithm, and we will see how much total time is required by this particular algorithm. So what we can do, we can assume that for execution of each line some constant amount of time is required, and since each line contains some different mathematical operation, we need to take different values for constants for each line. So we can say that, let's say, cost for execution of line number 1 is nothing but, let's say, c1. For line number 2, let's say it's c2. For line number 3, it's, let's say, c3. For line number 4, let's say it's c4. For line number 5, let's say it's c5. For line number 6, let's say it's c6, c7 and c8, right? As you can see here, we are doing comparison operation, right? We are comparing a of I with key, and we are checking whether I is greater than 0 or not, and here at line number 2 we are doing assignment operation, right? So therefore we need to take different constants, and as you can see, this line number 3 is just a comment, right? So what we can do, we can ignore this cost. We can say that, let's say, this value of c3 must be 0. Now this is about cost. Now we also need to find out how many times a particular line is executed. Okay, so cost is one thing. The second thing is about number of times a particular line will be executed, right? So as you can see here, we are starting from 2 and we are going up to n, and when we reach to the very last point, we will increment our value of j one more time by the rule of this for loop, and we can say that eventually we are going to execute this particular first line n minus 1 plus 1, which is nothing but n times. Okay, this and all these statements are inside for loop, so straight away we can say that the second line will be executed n minus 1 times, third line will be also executed n minus 1 times, but it will be ignored because it's a comment. Fourth line will be also executed n minus 1 times. Okay, now this is again loop, right? And we don't know how many times this particular line will be executed, so let's assume it's some quantity, let's say t time required to execute this particular while loop for a particular value of j, right? So initially my value of j will be 2, then it will go up to n. So what I will do, I will find out time required for, let's say, time required corresponding to value of j is equal to 2 for this particular while loop, then time required for execution of this while loop corresponding to value of j is equal to 3, 4, so on up to n, and we will sum all this time. So that will be total time required, right, for by this particular line 5. So we can write summation tj, j running from 2 to n. Okay, and since statement 6 and 7 are inside this particular while loop, we can say that time required by statement 6 is nothing but tj minus 1, right? It's similar to this n and n minus 1. Since this statement 2 is inside for loop, it will be executed one less time as compared to the main statement. The same is true with respect to this while loop, so we can write like this, and same is true for statement 7 also. So this will work for 6 as well as 7. Okay, and for the last statement, again it's inside my main for loop, so we can say that it will be executed exactly n minus 1 times. So now from this we can write down the generalized equation of time taken by this particular algorithm. So what we need to do, we need to find out total time required, total cost required by each line. So for the first line, if we consider the cost is C1 but it will be executed n times, so we can say that the total time required by line number 1 is nothing but C1 times n, because basically C1 amount of time is required for execution of line number 1 time, but we are executing it n times, so we can say that C1 into n plus for line 2 we can say C2 into n minus 1, and for line number, so it's like this: for one execution we require C amount of time, then for n execution or n minus 1 execution how much amount of time is required, so basically it's n into C, right? And for C3 we can ignore because value of C3 is 0, so we can ignore line number 3. For line number 4 we can say C4 into n minus 1, okay. For line number 5 we can say C5 into Tj, where j is running from 2 to n, and then for C6 and C7 we can say C6 into summation of Tj minus 1, and j will run from 2 to n, and for C7 also we can say it's Tj minus 1 and j will go from 2 to n, and for the very last statement we can write like this: C8 into n minus 1, okay. So we know everything except for what is the value of Tj. So now if you observe carefully, then value of Tj is dependent upon my input, right? So if my input is, so let me take one example. So let me take one input. So let's say my input is like this. So I have taken 6 numbers in my input, and these numbers are already in sorted order, as you can observe. And if you notice, then if I have this type of input, then while loop won't be executed at all, because for each value of key, which is nothing but a of j, the value of a of j will be greater than value of a of j minus 1, which is nothing but a of I in this case. So therefore this particular condition will be always false, right? And we can directly append the key value to the already sorted list, right? So therefore what we are going to do, there will be only one comparison corresponding to this line, and since this condition, this particular comparison will be false, this line number 6 and 7 won't be executed at all. So what we can do, we can substitute, for this particular case we can substitute value of Tj is equal to 1, right? And if this is 1, then we know that the next two statements, value of Tj minus 1 is nothing but it's 1 minus 1 0, right? So if we substitute this and this is corresponding to best case. Why this is best case? This is not the best case because these elements are sorted. This is the best case because this is the best possible case we can get in terms of less number of comparison, in terms of minimum number of comparisons for the underlying while loop, right? So this is the best we can do with respect to line number 5, 6 and 7, right? So minimum number of comparisons, right? So we can substitute value of Tj is equal to 1 here, and then we can simplify this. Okay, so let's simplify. So like I mentioned, I can ignore these two terms because they are nothing but 0. Tj minus 1 is 0, so we can ignore this two, and value of Tj is nothing but 1. So basically it's if we simplify more, then it's nothing but nothing but summation of 1, and for values going from 2 to n, so which is nothing but n minus 1, right? So we can substitute, instead of this we can substitute n minus 1, right? And now if we simplify this, then that particular, the modified equation will be corresponding to the time taken by the algorithm in the best case. So let me write down the modified equation here. So first term will remain as it is, which is nothing but c1 times n. The second term will also remain as it is, which is nothing but c2 into n minus 1, and fourth term c4 into n minus 1. But now fifth term is nothing but c5 into n minus 1, right? So because we are substituting the value of tj, so this is nothing but c5 into n minus 1. We don't need to write down term 6 and 7, and last term is c8 into n minus 1, right, as you can see here, right? So this is the time taken by the algorithm in the corresponding to the best case. And if we simplify this, then we can say that it's nothing but c1 plus c2 plus c4 plus c5 plus c8 times n. And now I will club minus terms, so c2 plus c4 plus c5 plus c8, right? And if you notice this, then this particular form is nothing but it's like ax plus some constant b, right? And in terms of big omega notation, we can say that it's nothing but, so instead of x, this is here it's n, so it's nothing but it's of the form a n plus b, where a and b are constants, right? So I should use small letters, so let me write down like this: small a n plus b, right? So we can say that this particular function, right, it's a linear function, and hence in terms of our asymptotic notation, we can say that at least order of n, right, order of n amount of time is required by this particular algorithm, and this particular time is corresponding to the best case. Thank you. Subscribe to my channel for more videos. In the next video we will talk about the worst case analysis for the insertion sort.